In this video, I'll be teaching you guys how to find the unions and intersections of a sequence of sets, denoted by this formula here. So what does this I stand for, and what does this A of I stand for? Well, in order to find the first term in the sequence, A of 1, we need to plug in 1 into I. So I is here. We replaced I with 1, so that means we have to replace these i's with 1 as well. So we put 1 here, we get 1 squared and 1 minus 1. And this should give us 1 comma 0, right? The set 1 comma 0. How about the second term of the sequence, A of 2? So remember, I in this case is equal to 2, so we just simply plug in 2 into the I values. So we get 2 squared comma 2 minus 2 is equal to 4 comma 0. You get what I'm saying? So whatever A of 3 is, this is just the third term in the sequence, whatever that is, you just simply plug in 3 into the I values in this kind of definition of the sequence here. So why did I bring that up? Well, we have this symbol here. We don't know what it stands for, but what we do know, right, from summations, if you've ever done summations, is that the bottom value is the starting number and the top value is the end number. So what is this? Well, we start off at I is equal to 1 and we end off at I is equal to 4 with the formula here. So we want to plug in I into this. So we want to plug in I is equal to 1 into this first, into this guy right here. So what is I is equal to 1 when we plug in here? Well, it's just simply A of 1, right? A of 1. So let's set this equal to, let's write out A of 1. A of 1 would just equal to 1 comma 0, so remember that. Now, what do we do between it, right? For summations, we add all the values, correct? But for this, we take the union in between all of these sets, right? This is the union symbol, so we take the union between all of these sets. Let's move on to A is equal to 2. Remember, we plugged in 1 into I first. That means we move on to the next number. So we move on from 1 to 2 to 3 to 4, right? And we ended off at 4 because 4 is the top number here. So let's plug in 2, right, into I right here. So 2 would be A of 2, which was 4 comma 0. Take the union. We need to find A of 3. So A of 3 is 9 comma 0, right? If you plug in 3 into I here, you should get 9 comma 0. And A of 4 is 16 comma 0. All right, and we ended off there because 4 is the highest I value that we are going to go to. And if we take the union of all of these sets, you should get 0, 1, 4, 9, and 16. Right? We just combine every single value in the set and we remove any single duplicate. Any single duplicate? I mean, any duplicate. Single duplicate. Is that like a oxymoron? Because duplicates aren't single. Okay, whatever. But for this one, what do? Well, kind of get the same thing, right? We start off at I is equal to 1 and we end off at I is equal to 4. So let's write down A of 1 first. But this time, instead of taking the union of all of these sets, we actually take the intersection of all of these sets. So we need to get A of 2 here to get 4 comma 0. Intersection A comma 3, 9 comma 0. And the intersection of A comma 4, 16 comma 0. Right? In order to find the intersection of all these, we just need to find the value that they all hold similar. So this one has a 1, but no other set has a 1. So ignore the 1. But what about 0? Well, every set has a 0. So 0 is in the total intersection of A of 1, A of 2, A of 3, and A of 4. Right? We don't have a 4 in any other set. We don't have a 9 in all other sets. And we don't have a 16 in all other sets. So 0 is the only similarity between all of these sets. Therefore, 0 is the answer. Just a singular set 0 is the answer to this. So for this one, we start off at 1 and we actually end off at 3. And we have a different definition of this sequence, right? We have I minus 3, we have a 4, and we have I cubed. So remember, we start off with I is equal to 1, so we plug in 1 into here. All right, so we plug in 1 into A of 1. What does that mean? We just get A of I, sorry. That means we just get A of 1. Okay, so we plug in 1 into A of I. So we get A of 1. If we plug in 1 into here, you should get 1 minus 3, which is negative 2. You should get a 4. And you should get 1 cubed, which is simply 1. Alright, and then we take the union with A of 2. So we move on to the next integer value for I. So now we move on from 1 to 2 to 3 for I. Right? So let's go ahead and plug in 2 into this to get A of 2. So 2 minus 3 is negative 1. We have a 4 here, just a 4. And 2 cubed is just 8. Alright, next. For the last number, we go into 3, right? We just end it off here because 3 is the number above this. So 3 minus 3 is 0. We just get a 4. And 3 cubed is 27. And remember, we're taking the unions of all of these sets, right? We're taking the union of the sequence of these sets. So how do you find the union? Well, combine all the values. I have a negative 2. We have a 4. We have a 1. We have a negative 1. Looks like we already wrote a 4 down, so we don't have to write down a 4 again. Let's write down 8, right? Let's write down 0. We already have a 4, so we don't have to write a 4 again. We also don't have a 27, so let's write down 27 into here. So this right here is just the union of A of 1, A of 2, and A of 3. Alright, how about this? Well, for this, we can kind of just copy and paste A of 1 to A of 3. Right, so let's go ahead and copy and paste this. But we need to find the intersection of all of these this time. And also, we have one thing that we missed. This right here goes up to 4. So I actually goes up to 4. So we need to take the intersection of A of 4 as well. So let's write down 4. So 4 minus 3 is 1. 4 is just 4. And 4 cubed is 64. All right. So what's the intersection between all of these sets, right? A of 1, A of 2, A of 3, and A of 4. Well, the intersection between all of these is just 4. Right? That's the only similarity they have between all of these sets, right? We have a negative 2 here in A of 1, but we don't have a negative 2 in all other sets. We have a 1 here, but we don't have a 1 in all other sets, right? You get the point, right? The only number that's in all of the sets is just 4. So the intersection, the total intersection between the sequence of A1 to A4 is just simply 4. Last problem. So we start off with I is equal to 1, and then we move on to 5. So the maximum value for I is 5 in this case. So let's go ahead and plug in 1 into I first. So we get A of 1 first. A of 1 is simply just negative 1, and 1 plus 1 is 2. Right? We're taking the union of all of these guys. So let's write down union in between the sequence. So we need to move on to A of 2 next. So A of 2 is just simply negative 2, comma 3. Union A of 3, negative 3, comma 4. And A of 4. Sorry, I need to write down union first. So A of 4, negative 4, 5. And union of A of 5 last, right? We're going up to 5 only, so we have no other sets in this sequence. So we have negative 5 and 6. Okay, once we get this, what do we need to do? We just need to take the union of all of these. So the union, I'll just start with the smallest number. So we have negative 5, negative 4, negative 3, negative 2, and negative 1. And we have 2, 3, 4, 5, and 6. So let's write down 2, 3, 4, 5, and 6. So this right here is the union of the set A of I from I is equal to 1 to 5. Right over here. Let's put it in a box, because this guy's special. Actually, before I put it in a box, let's copy and paste this. It's going to be very useful, because we're going to use the same thing. or the intersection, right? Okay, now I can put it in a box. Now I can. There you go. I'm a little quieter today. I can't like scream or actually I don't. Do I even scream in the other videos? I don't remember. I just kind of talk. I'm being quiet because my brother just came home. Also, my mom is still asleep. I'm recording this in the morning, so. And before you say I'm a shut-in, okay? Before you say, oh, you're a grown-ass man living in your mom's house, bro, I'm 19. Of course, I'm living in my parents' home. But let's finish this problem. Let's finish this problem. I'm probably gonna be like, if I rewatch any of my videos when I'm like older, jeez, man. Hey, when I get my PhD, well, that's my goal. I'm trying to get a PhD in quantum computing. I really like quantum computing. AI's kind of interesting too. I don't know. Maybe I'll delve into it a little bit. But basically, stop this. Let's stop this. So basically, what do we have here? We just need to find the intersection between all these sets now, right? Because we're using intersection here. So intersection. Let's remove all these union symbols. Get out of here. I hate unions. I want to pay my workers terribly. Let's put intersections here. All right. Now that we have this, what's the intersection between all these sets? Nothing. There's no similar values between all these sets, A1 to A5. Okay? So we just simply have the null set. So the null set is still a valid answer, right? It's just a set that contains nothing. The null set is also just simply equal to this set right here, right? The set that contains nothing, just two brackets. Okay? So that's it. That is it for the unions and intersections of sequences of sets. Okay? It's quite simple, right? All you need to do is take the methodical path and just plug in. I have one and then go up to here and then plug it into here. Okay, you get the point. But anyways, if you have any questions, put it in the comment section. If you found this video helpful, consider subscribing and liking the video. Thanks for watching.